when I factor using difference of squares, I'm actually factoring by what's called pattern. In other words, it's a quick way of factoring a very specific set of polynomials. So I look at the name. Difference makes me think subtraction. So I have to have subtraction in order to use this method. And squares in this case is referring to perfect squares. So if I have perfect squares subtracted from each other, then I can use this method. The thing that I look for is a binomial. If I have a binomial where these conditions are met, then I'm automatically thinking difference of squares. The key to using difference of squares is realizing that I'm looking for conjugates as my answer, because conjugates FOIL out to a binomial, which we've already seen. So I take my original problem, I look at it, and I realize I'm undoing some sort of FOIL, so I put the parentheses. The beautiful thing about conjugates is the middle terms cancel out, so in order to get my two pieces, I just take first times first. So in this case, I'm thinking what times itself is going to give me this x squared term. And I realize that it's x and x. Don't have to worry about the middle terms because they'll go away. I take last times last. So I think what's going to give me a 16. And I know that that's going to be 4 times 4. So I put the 4 and I put the 4. And since I have middle terms that cancel out and I'm trying to get conjugates, they have to be exactly the same except the middle signs are opposite. One is plus, one's minus. And it doesn't matter which one's plus and which one's minus. So my factored form is x plus 4 times x minus 4. Very quickly, just to FOIL that out to prove that I'm correct, so you can see the middle terms cancel out. When I FOIL it, I get x squared minus 4x plus 4x minus 16. So you notice how the middle terms cancel out, and it really is x squared minus 16. So difference of squares is a fast way of factoring out any difference of perfect squares. It can help me with much more complicated problems, something that looks really nasty like 25x squared minus 49. I have no other method to do this unless I consider these conjugates. I do have a difference of squares. 25 is a perfect square, so is x squared, and so is 49. So I can apply this method. I go ahead and just put my parentheses for my binomials. If you want to, you can go ahead and put your plus and minus because I know I'm getting conjugates. Now I have to think, what gives me 25? Well, 5 and 5. What gives me x squared is x and x, so it's 5x as the first term. And then what gives me 49 is 7 and 7. So my final answer is 5x plus 7, 5x minus 7. So difference of squares relies solely on this idea of conjugates. And it's not useful in all situations, but if we can use it in a very specific situation, it speeds us up a lot when we're factoring.